So what we're going to look at here in this first section today is just talk about functions. And one of the things we want to do is just kind of talk about them a little different maybe than you have. So a function. Function is a rule that assigns to each element in a set D exactly one element called f of x in set E. So this is, you've heard this before, right? Domain and range of our function. One of the things that we really want to stress is the different ways we can represent a function. We're going to have, as the title of the note say, 4 kind of different ways to represent functions. And function is just the math way of saying some rule that assigns one number to another number, right? So if we think of the easiest function from like your algebra 1 days, if we had something like this, there's a function, right? There's a rule, and if we pick a number, and I just pick a random number, pick a number. 7. And I put that in, what number does this rule assign to 7? Well, you just plug 7 in for x, and you get 15, right? That's all we're talking about when we talk about a rule that assigns an x into a y. That's normally how we talk about it. Could be other variables, okay? We could also do this from looking at like a graph. This is kind of known as more of a piecewise or kind of a graph. So we remember this from before. If we wanted to find f of 1, here is 1, 2, 3, 4. So at 1, you say at 1, the function is at what value? 1. So f of 1 is 1. From there. At f of 2, you go to 2. Now you remember open and closed circle. Open and circle doesn't mean you don't include it, right? Closed circles you do. So at f of 2, we go through the open circle, we go to up there, and we get. Just so we're not confused here with the numbers, think about f of 3 and f of 4. We're going to do those. What would they be? F of 3 would be 2. F of 4 would be 1. Now, our domain and range. The domain, remember, are all the x's, and the range are the y's. So when we look at the domain, what is our x's? Well, our x's go from 0 all the way to 4. So my domain, I just wrote 1. Sorry. My domain is 0 to 4. If I wanted to look at the range, those are the y's. So it goes from 1 up to 2. Like that. Now, understand the brackets. Let me look at a second one here just so we understand. So let's say I had something like this. 1, 4, 1, let's do this. 2, 3. And I was like, open circle, close circle, open circle. Something like that, okay? So now if we wanted to find the domain and range, now it goes from 1 to 4, but I wouldn't have brackets because it's an open circle. You would have parentheses, right? So it would be 1 to 4. And then the range, it would go from 2, but what would we have at 3 because it's a closed circle? We have a bracket. That kind of, remember that with the brackets and parentheses for open and closed circles. Kind of connecting that with what we looked at. difference quotient. So let's look at this difference quotient. Now, one of the things I'm going to do this year, I'm going to try this. One of the new things I would say, try, is this idea of listen first. I'm going to do this first example. It's not on your notes. Just put your pencil down, do not take notes, and just listen. I will then do some more examples that are in your notes to work through. But I feel sometimes people are taking notes so much, they don't just like stop, listen, pay attention. So that's what we're going to do. So difference quotient. I don't know, have any of you got to the very end of the delta math? Okay, so if you've gotten all the way to the end, the last question on delta math is this kind of question. So if you got there, then we looked at one person and she's already got there and like did it, but it took, she got a whole bunch wrong before she like then eventually figured out what was going on. So if you haven't got there, you're good. So here's how the difference quotient works. So let's imagine for a second, kind of we'll break this down. We have f of x is x minus 3. What would be f of 5? 2, right? So what would f of 4 be? 1, okay? What would f of a be? It'd just be a minus 3, right? You're just plugging it in, right? So what would f of h plus 4 be? You would just plug in h plus 4. So you would say h plus 4 minus 3. Just see how we're substituting that in, okay? Now, if you notice, these two right here are what we're going to use here in a second. So what we want to do is we want to evaluate this, what they call difference quotient, which is this fraction. We're going to eventually add more to this, and it will become useful for something. Right now, we're just doing algebra just to do it, and it seems kind of like, doesn't make sense why, but eventually it will. So we have f of 4 plus h. Well, f of 4 plus h is just this, right? So I would say 4 plus h minus 3. F of 4 is just 1. So when we do this, we always do this. We always put, just to help us out, I'm going to put brackets around this to help us keep things organized. This is about just being like neat and organized so you can keep track of stuff. And then you're going to simplify. And what always, always, always happens is if we multiply this out, we have 4 plus h minus 3 minus 1 all over h. So what always happens is all of the numbers without h, 4 minus 3 is 1, minus 1, all these numbers cancel, right? That always happens. And then what you're always going to be left with is some h's on the top, some h's on the bottom, which can simplify. In this case, the answer is just 1. Let's do an example. So here's the example in your notes. There you go. There's nothing. Yeah. So in our notes, we have f of x is 2x plus 1, and we're going to use the exact same difference quotient here, 4 plus h minus 4. So first off, I'm just going to write it over here so we can be thinking about it. F of 4, if you put 4 in there, is 9. And f of 4 plus h problems are really just like a lot of algebra that from algebra 2 and stuff. So we plug those two in there. Okay. Now we come over here. The first one, I want to put brackets around and have 4 plus h. which would be 2, 4 plus h plus 1. And I'm going to color code this. And now we want to put 4 f of 4, which from over here is just 9. So when we do these, this first block will always have the h's and stuff in it, and then this second block is just going to be the number. So we now distribute this, and this is 8 plus 2h plus 1 minus 9. And you're going to see what happens to all of the numbers. 8 and 1 for 9. This cancels. That always cancels. And then what we're left with is just 2h over h. Those h's will always be able to cancel. And now you're left with just 2. That's the process. All right. Do another one. So we have x squared minus 2. And we have f of 3 plus h minus f of 3 all over h. So let's kind of break this one down. Step 1. Find those two. Let's see if you can do that first. Find f of 3 and f of 3 plus h. Now, once you do a couple of these, if you get pretty good, you don't have to write them down over there. You can just go right to the difference quotient once you kind of start understanding what you're doing. One tip I can give you when you're doing these kind of algebra problems that maybe there's like a lot of stuff to keep track of is come over here and simplify this here first instead of putting it into the big problem. So as we talked about back on Tuesday, 3 plus h, this would have to be 3 plus h, 3 plus h, and I'd have to FOIL, first outside, inside, last, which would give me 9 plus 6h plus h squared. Then I would have minus 2. So I get to that. Now, I'm now ready to put this back in our equation. So if we come back up here, this 3 plus h was h squared plus 6h plus 7. Minus this, which is 7 all over h. Everything without an h cancels. The 7's go away. So 6h plus h squared all over h. Now when I cancel the h's, I'm left with just h. All right, I'm going to skip the one at the bottom. And let's go to the back. So you try setting that one up on the back. I'll give you a second to do that one. We'll kind of work your way through that one. So notice we have f of 1 plus h minus f1 over h, and our function is 2x squared. So you try that out. So we have f of 1 is 2, f of 1 plus h. That is going to be h squared plus 2h plus 1. Gets to there. So now when we put it back in, we have 2h squared plus 4h plus 2. 2h. 2's cancel. 2h squared plus 4h h, which is 2h. I think I have, nope, I do not have the one on the front. The front of your notes, there's an additional problem, which you can see I'm not going to ever give you one like that. If you look on the front, the bottom of the front, you will see we have x cubed minus 1. So let's just say we had f of 2 plus h minus f of 2. I'm just making that up. If you had something like that, and you had to figure that out, you had to cube it, you'd have to like square it first and square it and then cube it. I'm not going to make you multiply that out right now to try to figure it out. So I'm skipping that one because that's much more work than we need. All right, last thing I want to do here today is I want to talk about the 4 representations of a function, and then we'll stop there. So our 4 ways of representing a function. The first one is verbally, and that is just a description in words, right? So if you look at the example on your paper there, 2 times a number plus 3. That is a verbal description. 2 times a number plus 3. So you just write it out in words. That's one way to describe a function. The second way is numerical. Table of values. So what that would look like is like that. Sometimes we'll be given a function in words. Sometimes we'll just be given a table of values. One of the things they like to do in calculus is to give you your functions we're working with in different forms, in words and a table of values. But you can see here, 2 times a number plus 3, 2 times 2 plus 3, that's the value. Third one, visually or graphically. I have a tendency to say graphically. I like that word better. I like graphically better than visually. And I think it's just cooler to say. So I think it sounds better. There would be graphically. It's just a graph of the function. And our final way of doing it is what's known as algebraically. And this is with our formula. This is our old calculus textbook. We don't use this one anymore, but you can see this one actually has in the title Graphically, numerically, algebraic. Because it's like dealing with calculus and doing calculus in all three kind of methods. So when we talk algebraically, it's the formula. So there is our four ways. You can see how we have it verbally. You write it out in words. You have a table numerically. You have a graph, which is graphically, and usually the vast majority of the ways, we have it written algebraically like that. We also could write this in function notation like that. So 2 times a number plus 3, usually that's how we write it, right? We deal with it that way. But they may give it to us in any one of those forms.